right here, we can see that this is what we had before, where it was from the radius, and we are actually twice the distance away. So that's why we have to do that 2 times or divided by 2. Yes. But this particular angle, you can see, goes right past the center point and actually has the vertex over here on the edge of our circle. So that's what makes it an inscribed angle. So whenever we have a vertex over here on the side, it is called an inscribed angle. All right, and that means that the arc over here that it opens up to would be called an intercepted arc. Now it's important that we are able to tell what piece would be considered the intercepted arc, because that measurement is going to help us out when we need to find our angle measure. So kind of like in football, you have interceptions. Right here, we are intercepting this part of our circle. So it is called an intercepted arc. Let's take a look at our formulas we're going to be using today. So if we are wanting to find an angle measure, it is going to be smaller than the arc. So we take the arc degree that it opens up to, and you're going to have to divide it by 2. If you want an arc measure, you will take the angle and times it by 2. So you're either going to divide by 2 or multiply by 2 today. Now if we look back, all right, here is example 1. Now we got a lot of stuff going on in this picture. Okay, take a look at that. We have 2 chords and a diameter. Now, knowing that that is a diameter there, TR, that is going to help you out quite a bit, because diameters cut your circle in half. So this right here, TQR, woo, that's a semicircle. And we know that these 2 pieces right here have to add up to 180. Now, if I use my formula, I can take angle R and times it by 2. So 50 times 2 is 100. So that would be the arc measure right here for QT. This is 100 degrees. I'm really wanting to know what is the arc measure for QR. So since this makes a semicircle, I can say 100 degrees from 180, because there's 180 degrees in a semicircle. If I can write this down, man. All right, so this right here would be 80 degrees. Wonderful. So that's the first thing they are asking for. The measure of R equals 80 degrees. Now the next thing they're wanting us to solve for is the measure of angle T. So if I look at angle T right here, it is opening up to this arc RS. So to get an angle, you got to take the arc that it opens up to and divide it by 2. So 48 divided by 2 is 24 degrees. Let's take a look at another. All right, now sometimes you're going to have pictures like this. We do not have any diameters in this picture, but what I wanted to point out for you, angle D, if you look at how it's opening, opens up to arc AB. But angle C, when you follow it, also opens up to the same arc. So what this means is angle D is congruent to angle C. That's what you need to be on the lookout for. If they open up to the same arc, they're going to have the same angle measure. All right. So looking at inscribed polygons, this blue circle that is containing this triangle would be called a circumscribed circle because all of the edges of the triangle are happening on the edge of the circle. A quadrilateral four-sided figure can be inscribed if and only if its opposite angles add to 180 degrees. That's the only way that it will fit inside our circle. So let's take a look at one of those. All right, we have a quadrilateral here. The only way that this will work is if the opposite corners add up to 180. So they're wanting us to solve for x and y here. So I'm going to take this set first, and they have to add up to 180. So I can say x plus 120 equals 180. So when I subtract the 120 over, I get x equals 60. So there's my first answer. I can also do the diagonal this way. Now because this is an easier one, of course we can just say 180 minus 80 and get the y equals 100. But they're not always going to be this easy, so keep in mind you might have to set it up and add it up to equal to 180.